9.5. Graph and write equations of hyperbolas. A hyperbola is a set of all points P such that the difference of the distance from P and two fixed points. So let's remember those fixed points. Those are our foci or foci. And so it reminds me a lot of our definition of an ellipse. So with an ellipse, when I add those two distances, it's a constant. With a hyperbola, we're looking at subtracting them and getting a constant. So just to do a quick review, we had circles first, and circle was x squared plus y squared equals a squared. And we found that we could also write it as x squared over a squared plus y squared over a squared equals 1. Then we looked at ellipses. So for an ellipse, instead of going a units in the x direction and the y direction to create a circle, we ended up with different numbers. So we have x squared over a squared plus y squared over b squared equals 1. So we don't have a circle anymore because we're stretching different amounts in the x and the y direction. We also had an equation for our foci. When we're working with an ellipse, our foci was c squared equals a squared minus b squared. And we made sure to always subtract big minus little. We didn't really worry about memorizing a and b. We just know x is over a number squared, y squared is over a number squared. If we're trying to find the foci, subtract them so that you get a positive. And now we're looking at hyperbola. So our basic equation for a hyperbola, there's really two. We'll look at them in a second. But I'm just going to write one with x squared first. Could be x squared over a squared minus y squared over b squared equals 1. So there's a lot of similarities between these three, and I just wanted to kind of look at those all together. Our equation now for our foci will be c squared equals a squared plus b squared. So with the hyperbola, we have a minus in the equation, but a plus when we're finding our foci. With the ellipse, we have a plus in the equation and a minus when we're finding the foci. So we're going to dig a little bit deeper into the anatomy and equations now that we use for hyperbolas. So let's go ahead and look at this parabola, or this hyperbola on the left. A lot of kids like to talk about how it's kind of like two parabolas put together. And I can see why it reminds you of that, but the definition of a hyperbola is different. So this one, my actual hyperbola graph, is just this little curve over here, and then the other one that's on the left. So that can kind of help you see why some kids talk about why it looks like two parabolas. So that's the actual hyperbola. The rest of that stuff, the box and those dashed lines that go from corner to corner, those asymptotes, those are just to help us find the graph. So when I'm looking at the standard form for a hyperbola, I'm going to start out with x squared over a squared minus y squared over b squared equals 1. I'm looking at this first hyperbola still. The transverse axis is the direction that it opens in. So always looking, does it open along a horizontal axis or a vertical axis? So with this one, with this equation, with this graph, our x is first because we have x squared minus y squared. And so we're looking at a horizontal transverse axis. Saying x-axis on this one is technically right, but remember we can shift these from the center. So we really want to think about a horizontal transverse axis instead. But if you want to think x-axis in your head for what we're doing right now, it will work. You just got to watch out you're not confused later on. The next important thing that we want to list are asymptotes. So asymptotes are these dashed lines that go through the middle. So our asymptote goes up b units in the y direction and across a units in the x direction, because y is over b squared and x squared is over a squared. So that's where that comes from. Or we could go b units down and a units to the right and get the equation for that other line. So we'll write this as y equals plus or minus b over a times x. So think of like y equals mx plus b. Only our b value, our center, is the origin. So there's really a plus 0 at the end that we don't need. But we're just writing a y equals mx plus b equation. I'm going to erase that plus 0. So when I'm looking at my vertices, I have two. I have one on this side for that section of my hyperbola, and then one over on the right. So those are going to be, because this opens in the x direction, it's going to be that number that x is over to the right and the left. So x squared is over a squared, so it's going to be a units to the right on the x-axis and a units to the left. So that means plus or minus a comma 0. Now we're going to look at the hyperbola that opens in that y direction, where I have a vertical transverse axis. And it's vertical because y is first in the equation. So my equation is y squared over a squared minus x squared over b squared equals 1. So my asymptotes now, that should be a squared, are going to be up a units in the y direction over b in the x direction. So y equals plus or minus a over bx. And my vertices are going to be on the y-axis instead. So I have 0 comma plus or minus a. And then here I have the equation for the foci again. C squared equals a squared plus b squared. Another interesting thing to think about with the foci that I want to point out, and was when we were looking at an ellipse, my foci were inside the ellipse. When I am looking at a hyperbola, my foci are outside. They're not in between, right? Like here's one shape, and then it lies above that. And here's the other part of my shape, and it's below that. So a lot of times kids expect those to be kind of in between those two curves, and they're not. So just something else for you to think about. For example 1, we're given an equation for a hyperbola. And I know it's hyperbola because my y is squared, my x is squared, and there's a minus sign. That's what I've got to look for. I'm going to identify vertices, foci, asymptotes, and I'm going to obviously graph it. So let's start by putting it in standard form. So I know standard form would be equal to 1, so I need to divide everything by 36. So we'll have y squared over 9 minus x squared over 4 equals 1. I like to graph everything, and instead of memorizing all those letters and all that stuff we kind of looked at when we're looking at anatomy of a hyperbola, I like to graph and just get my information from the graph. It's less room for error. You're not memorizing a bunch of stuff. It's just easier to work visually. So in order to graph our hyperbola, our first step is going to be to draw the box. And we need to remember if y squared is over 9, my y is 3. If x squared is over 4, my x is 2. So because my x squared and my y squared, there's no plus or minus anything. I don't have a quantity x minus 1 or a quantity x plus 7 or y plus 1. The x's and y's are by themselves. My center's at 0, 0. I'll move 2 units in the x direction, right and left, 3 units in the y direction, up and down. And then it's kind of like drawing an ellipse, but I'm not drawing an ellipse. I'm going to connect all of those points and make a box. So hopefully you kind of see the similarities between this and the ellipse. We really want to build on that idea of what we did before with the ellipses. It'll make memorizing hyperbolas and working with them a lot easier. Our second step is to draw asymptotes. And the asymptotes are corner to corner in the box. They are not just random lines on here. And I'm going to continue drawing dashed lines. I like to draw the dashed lines because all of this stuff is just a setup to draw the hyperbola. It's not actually the hyperbola. And when I'm not working on a flat screen tablet, I really like to use a ruler to connect those corners of the boxes. Here's the other 2 corners. So that's really what I was connecting. Our third step is to add our vertices. So we're getting closer to graphing. Because y is first, the vertices are y. So that, remember, means that we have a horizontal transverse axis. Or sorry, vertical transverse axis. Because y is going to be our vertical axis. So this is going to open vertically. So I'm going to change a different color here. So I'll have one vertice right here and the other one right here. So it's on that box, but we don't have 4 of them. We're only drawing them on the side that we open to. And since y is first over here, our transverse axis will be vertical. We're going to put everything on that y-axis. For step 4, we're going to draw a hyperbola. So we're almost done. When we draw the hyperbola, this is creative spelling. When I draw the hyperbola, I need to go close to the asymptotes and through the vertices. So remember, with asymptotes, definition of an asymptote is you get closer and closer, but you don't ever touch, but we've got to go through those vertices. Now we're going to go through and identify all those parts. So vertices seems like it'll be an easy place to start. We had a vertice at the top and the bottom of that box. So it looks like 0, 3 and 0, -3. And you could get that by looking at the equation, but it's so much easier to look at just the graph. The foci I know are going to be out, so we'll have one up here and one down here or something like that. But I'm going to need to use that equation to solve for them. So let's go ahead and do that. Foci, maybe I'll put them over here where I have space. C squared equals a squared. There's a minus in my hyperbola equation, so a plus sign here. A squared plus b squared. And it doesn't matter which number I put in for a squared and which one I put in for b squared, because we're just adding. So I just need to add 9 and 4, or 4 plus 9, either way. So c squared equals 13, and we'll do the square root. Absolute value of c equals square root of 13, and so c equals plus or minus square root of 13. So when I write down my foci, remember those are going to be on my y-axis. My transverse axis is vertical, right? So they've got to be up and down from that center. So my foci will be 0, comma, I'm just going to use a plus or minus this time, plus or minus square root of 13. You can write them as 2, you can write it with the plus or minus. Sometimes teachers will have a preference, but either way is fine. Last part of this is doing the asymptotes. So we know our asymptotes are going to be y equals mx plus b equations. And in this case, b is 0, because our asymptote lines go right through the origin here. So let's go ahead and count out the slopes for those. So I have one line that starts here at the corner and ends here. So I could go up 6 over 4, or I could just do one little part of this. I have up 3 over 2. So that's going to be y equals 3 halves. I don't know where to put this. We'll put it over here. Times x. I could have done 6/4, but then I'd have to reduce. For this other line, the line going down, it's going to have that same slope, but it's negative now. So I'm just going to change this to plus or minus 3 halves. And I'm just going to label this asymptotes. All right, next example. A lot of information packed into this one. For example 2, we're going to write an equation. So before we were working with an equation, we were given one, we had to put it in standard form, graph it. Now other way around, they're giving us some information and we're going to write an equation for the hyperbola. And we know the foci, -8, 0, and 8, 0, and the vertices, -5, 0, 5, 0. So what I notice is my y's here are all 0. These are all x values. And because the x is the number here, then x will be first in the equation. So x will be first. And I'm going to write x is the transverse. And what I really mean by that is that it's horizontal. So I have a horizontal transverse axis. So let's just write down kind of the standard form for how this looks. We'll have x squared over a number, because we know the x has to be first, minus y squared over a number, and then it's going to equal 1. So we know that the vertices are going to give us this number that x squared is over, because our box was drawn 5 units to the right and 5 units to the left, and that's where we put our vertices. So we know the x squared over 5 squared part right away. So we have, like, let's call that A. And we know when we have the foci, we kind of have C, don't we? So we need to do that equation. C squared equals A squared. There's a minus in my hyperbola equation, so this is a plus. Remember, those are opposite sign. So I've really got to solve for the thing I don't know. So I'll write 8 squared equals, I'm going to use positive 5 squared because I could sub either 1, plus b squared. 64 equals 25 plus b squared. We'll subtract 25 on both sides. So 39 equals b squared. And I could keep going, but I know the value, it needs to be y squared over a number squared anyway. This is already b squared. So I can just use the 39 right now. So x squared over 25 minus y squared over 39 equals 1. We've got the equation. Last example. A military plane is flying along a hyperbolic path with focus at 0, 2 square roots of 3. So that's going to give us C. And we'll go through a point 0, 2. Okay, so this is going to be like our vertice, right? Let's just call it, I don't know if I should say vertice or vertex, because we're only looking at half of a hyperbola, but we're going to write an equation for a whole one. So I think I'm going to leave it as vertice. So 0, 2, so I'm going to label that A. The center of a town below the flight path is located at X. So X right here is going to be our town. First, we're going to write an equation for the path of the plane. So this seems a lot like the last problem we did. Now this one I can see is opening into the y direction. So my vertical axis is transverse. Y squared has to be first. So y is transverse. And really by that I mean vertical. And so y is first in the equation. So I will have y squared over a number minus x squared over a number equals 1. And I can figure out the number for y squared right away because I have 2 as my the vertex I'm given. This will be 2 squared. And just like the last one, I'm going to have to solve c squared equals a squared plus b squared to figure out the number with x squared. So c was 2 square roots of 3 squared equals a squared I'm going to use as the 2 squared plus whatever b is squared. When I square 2 square roots of 3, I have to square the 2 and the square root of 3. So 4 times 3 now equals 4 plus b squared. So we will have to subtract 4 on both sides. And then again, even if I find the value of b, I have to go back and square it anyway for my equation. So I'm just going to stop here and write 8. So I have done the first part of this equation. I've written first part of this problem. I've written an equation for the path of the plane. So I'm going to go ahead and kind of box that in to show part 1. Now I want to know how high is the plane when it's directly above the center of town. So I'm going to look at this diagram again. So the town is 3 miles to the right. To me, that really says x is equal to 3. If I want to know how high this plane is, I am really looking for the y coordinate. So I'm looking for 3, something. That's going to be a point on that hyperbola. So I'm going to substitute x equals 3, and then I'm going to solve for y. So now I have y squared over 4 minus 3 squared over 8 equals 1. I don't like solving equations with fractions if I can avoid it. We can always make math easier. So I'm going to multiply through by 8 to cancel out all my denominators. So when I distribute, the 8 divided by 4 would give me a 2y squared minus 8 times 3 squared but divided by 8. It'll just give me 3 squared, so I'm going to write 9 equals, and then 8 times 1 is just 8. So now we have an easier equation to solve. We'll add 9. 2y squared equals 17. We'll divide by 2. Normally, I would just leave this as a fraction, but we want to know the actual height. We don't want to have one of those math things where we have like a weird square root. We want an actual number. We want a decimal. So I'm going to call this 8.5. I'm going to continue over here. So I'll have the square root of y squared is the square root of 8.5. And then I'll have absolute value. And this is because there's really two halves of that parabola. Or hyperbola. Sorry, now I'm saying it. But we only want part of that hyperbola. Like the negative part doesn't make any sense. The plane's not going to fly below the Earth. So I have plus or minus square root of 8.5. But really I can reject the negative. So y is going to equal the square root of 8.5, which as a decimal is about 2.9 miles. So approximately 2.9 miles up in the air from the town.